Okay. Um, hmm. I'm not reconsidering my career choices. No, 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 no. We're on day 75 of graphing. Um, man, uh, there's a lot of graphing in Algebra 2. I didn't realize that. I'm trying to think if there's a lot of graphing in pre-calculus. I don't know. I think so. I think it like starts with graphing. Okay. Yeah, no, I made the correct career choices. I got this. I got this. Growth mindset. All right. It says state the amplitude, period, phase shift for each function. Not to be a downer, but I feel like phase shift is the hardest. Period's not bad. We did that a bunch. I don't know. Amplitude's not bad. I don't know if like tangent has an amplitude. Eeks. I don't even know. I wouldn't say tangent has an amplitude. I don't know what it was. Give me 1 second.
Who are you talking to?
It's a pretty green. All right. So I'm working on 15 and tangent theta. I'm changing degrees to radians. I'm sorry. I just don't degree. I don't degree. Oh well. Pi over 2. Okay. So I don't believe tangent has an amplitude. It just feels weird. It's like a false generalization. So I'm gonna say there's no amplitude for tangent. Maybe they just want one, the coefficient in front of tangent. I don't know. Maybe. The period. We know period for tangent is pi. This isn't going to change. It only change if y is equal to tangent if there was something in front of it, like b theta. And you would compress by b, so you divide by b. And the normal period is tangent, so it'd be like tangent over b. The phase shift. So we've done this many times. When it's with the x, it's going to move in that opposite direction. So we have a minus pi over 2. We have a minus pi over 2. So therefore, it's going to shift to the right pi over 2. That's its phase shift. Its phase shift is its horizontal shift. I don't know what they call the vertical shift. The vertical shift is vertical shift. Okay, perfect. Yeah. Kind of the phase shifts, it's almost like a science term. It like refers to hertz, frequencies, and stuff like that. I might go over that. I haven't decided yet. All right, or your teacher may go over it. All right, so let's graph this. So what I'm going to do is I'm going to graph the base function, y equals tangent theta, and then I'm going to phase shift it. So y equals tangent theta. Again, I'm assuming we know how to graph this. I'm going to graph, let's see, so here's 2 pi, here's pi over 2, here's negative pi over 2. So this is like a bad graph. And then my horizontal asymptotes are going to be at pi over 2. Hopefully you understand that. Here's 3 pi over 2. Here's 3 pi over 2. Okay, perfect. And I'm just going to have one period. I don't know where we want to have our one period at. Maybe or 2 cycles or 1 cycles, but I know my tangent graph looks like this. So I'm making the assumption you already know how to draw a tangent. So I'm not plotting points. I'm already making that assumption. So that's what my tangent graph looks like. And I'm going to move right pi over 2. So, man, like imagine this point here is going to move over pi over 2. All right. And this point here is also going to move pi over 2 like this. Basically, my vertical asymptote is also going to move pi over 2. This vertical asymptote is also going to move pi over 2. And then we get a graph that looks like this. And if you notice, the shift is pi over 2 to the right. Again, kind of terrible picture, but our green one is our new graph here. Looks like that. Again, we shifted pi over 2 to the right. Yeah, it's tricky. It's tricky. I think in the next graph, so I'm going to dot my graphs. I don't think that was too terrible. All right, 17. We got y is equal to 2 sine theta plus pi over 2. Exactly the same thing. Amplitude is 2 this time. Let's see, it says find period. Period for sine is 2 pi. And it's being shifted to the left, pi over 2. All right, so I'm going to draw my standard y equals sine graph, y equals sine graph. I guess y equals 2 sine graph. Okay, so this is 2, this is negative 2, and this is 2. This is 2 pi, this is pi, this is pi over 2, this is 3 pi over 2, and then my regular sine graph looks like this. Again, I'm assuming we know how to graph. Point, 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 and this is my regular sine graph, but I'm using this for like my final graph. So we are shifting every point to the left by pi over 2. So I'm going to put a negative pi over 2 in here, and therefore this point here is going to shift over pi over 2. So boom. And this point's going to shift pi over 2. And this point's going to shift pi over 2. And this point's going to shift pi over 2. And this point's going to shift pi over 2. And then we have this kind of relationship. And if you look, right, and assuming these things repeat themselves, right, so you're going to have like this green line is actually the cosine function. So it turns out that sine and cosine differ by pi over 2, but I think that should make sense. I hope. I mean, just look at the unit circle and then like rotate it. See, look at the unit circle. I don't know why I'm doing this. Rotate. It actually becomes a big idea. We'll use it in the future. 0, 1, negative 1, 0, and then 0, negative 1, and then imagine rotating it this way, pi over 2, and like rotating it. I don't know. Maybe this graph here makes more sense than the unit circle. All right, on to the next problem. 18. No, wait. 19. I'm doing the odds. It was like 15 to 30. Your teacher, dude. Oh my God, that's so many graphing problems. All right, 3 cosine theta plus or minus pi over 3. See, this is going to be really hard. Like, this becomes not fun at all. Okay, I'm just gonna go with it. All right, amplitude is 3, period is 2 pi, so there's no number in front here. There's no number in front. The phase shift is pi over 3 to the right. So I'm gonna graph our regular cosine function. Y is equal to 3 cosine theta, and then I'm gonna shift that. So here's 2 pi, here's pi over 2, and here's 3 pi over 2. And then, I'm going to plot the cosine here. Cosine will look like meow, 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 meow. And again, this will be 3 and negative 3 as my amplitude. And I'm just going to draw this in lightly. this is my cosine. And then I'm going to shift all these values pi over 3. Well, pi over 3 is just left of pi over 2. So that's my pi over 3, right? And then that's my next pi over 3, which turns out to be 2 pi over 3. And this is my next pi over 3, which turns out to be 4 pi over 3. And this is my next pi over 3. Am I shifting to the right or to the left? I'm shifting to the right. And this is 5 pi over 3. Okay. And then there's one more pi over 3. I think I'm going to go draw here. This will turn out to be 7 pi over 3. Yeah, I think that's right. And then all my points get shifted to the right. This amount, pi over 3. So boom. And then this shifts over. Boom. And then this shifts over. Boom. And then this shifts over. Let's see, I got boom. And this shifts over. Boom. And then this shifts over. Boom. And so I have these new points. Boom, 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 boom. And then finally, boom. I don't know why I didn't draw that. And then here's my new graph that's been shifted to the right, pi over 3. Phase shift's the hardest. It is. Like, my graph looks terrible. It's awful. It's like my boss. If your teacher saw that I would actually watch these tutoring videos, then he would fire me because this looks awful. But there it is. It's a cosine shifted pi over 3. Wasn't terrible. Okay, vertical shift is easy. Vertical shift I can do all day. Well, kind of. Tangent's pretty terrible for vertical shift though. I'm gonna draw it. I'm just gonna draw that period in between. So let's see, this is pi. This is 3 pi over 2. This is pi over 2. And I'm just gonna draw this period. Like the period between pi and 3 pi over 2. And then here's my graph. That's my tangent graph, one period. Hopefully you're comfortable with the tangent graph. And then we've done this many times. There's like not a new lesson here. What happens with that -1? Well, the whole thing's going to shift down 1 unit. So imagine taking every single point and shifting it down 1 unit. So imagine here's 1. Here's 1. And so what is this going to look like? I believe it's going to look more like this. You know, that type of thing. Again, the tangent shifted 1 unit down. And it's not like perfect, but more or less the same. All right, 20, 23. Now this is y is equal to 2 cosine theta minus 5. Wondering how I'm going to do this. No, I know I'm going to do this. All right. I'm thinking about drawing the midline first. I think it's going to be easier. Okay, so normally speaking, when we're talking about sine or cosine function that hasn't been shifted, the midline's on the x-axis, right there. Now this says it's going to shift 5 units down. I'm wondering if I should do this or not. I'm going to do it because I just want to draw it once. I don't want to draw. I mean, either or, it doesn't really matter. But I'm going to drop the midline 5 units. So I'm going to say right here is 5. And that's my midline. Normally, we'd go from -2 to 2 because of this 2. If this is the midline, it should make sense. We're going to go an amplitude. We're going to go up 2, and we're going to go down 2 from the midline. So we're going to go, I guess this is -5. We're going to go -3, and we're going to go -7. I hope that makes sense. We have an amplitude. All right. And I'm still going to do my 2 pi out here. And I'm going to do my pi. And I'm going to do my pi over 2. And I'm going to do my 3 pi over 2. 3 pi over 2. And then I'm going to draw my cosine function. So my cosine function looks like, and it looks like this. Oops. Again, this has an amplitude of 2, and it's been shifted down 5 units. This distance is 2, and this distance is 2. We go up 2 from the midline, and we go down 2 from the midline. I feel like that was easier than graphing it like the original one, and then shifting each one. Now, in terms of phase shift, you have to do that. Like, you have to move each point. But I feel like this one, if you move the midline, I think it makes it easier. I think. I feel like maybe we should do it both ways. Maybe. Come on. Seriously? An amplitude of 1/3? Jerkos. All right, here we go. 25. Y is equal to 1/3. Why? Why would you do that? Whatever. Okay, so I'm going to do that whole moving the midline. So, boom, 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 boom. Okay, so I'm going to say this is my normal X and Y, but I have to move it up 7, so I made myself space. All right, so normally it would go down to -1/3 and up to +1/3. But now we're moving our midline to Y equals 7. We're moving up the whole graph, and that's our midline. And then we have a, if this is 7, I kind of don't care. This is like 7 minus 1/3, and this is 7 plus 1/3, where these things are both 1/3. But I really don't care. This is 2 pi, and this is pi, and this is pi over 2. Again, I'm assuming we're experts at graphing these trig functions before we transform them, move them up, and phase shift them, and do all that stuff. So here is my awesome sine graph. Whee! Again, it's my sine graph that's been shifted up units and has an amplitude up 7 units and has an amplitude of 1/3. Why is it 1/3? I don't know. Jerkos is what it is. Okay. I feel like we're halfway through, but now we have the hard part. And they combine all of it. So they're doing phase shift, they're doing vertical shift, they're doing change in periods, they're doing amplitude, they're doing it all. So 27 looks rough. It is rough, but we'll go through it. Okay, 1/2. Okay, theta minus pi over 2. I know it says 90 degrees, but it fuses in degrees. There it is. Perfect. Okay, I'm going to graph. You never include the phase shifts. You can't, you have to, just do the phase shift at the end. Technically, you could do it in the beginning, but, the order's not going to matter. Oh, hey, one more important thing. This has to be factored out. So if it's not factored out, make sure you factor it out. Hopefully your teacher will go over why that's important in class, but not right now. All right, so I'm going to graph y equals cosine 1/2 theta plus 2. That's what I'm going to graph. Amplitude is 1. Period is 4 pi. The whole 2 pi is a regular period, but we're condensing by 1/2, so we get 4 pi. Phase shift is pi over 2 to the right, but we're not going to worry about till later. That's our last thing we're going to do. And then we're going to do a vertical shift of 2 units. Again, the order doesn't really matter. You can do these in different orders and still get the right answer, but I think this is the best way. I think. All right, so I'm going to graph this. Here's my x and y axis. All right. It says we're shifting up 2, so I'm going to move this 2 units. This is y equals 2. I'm going to have an amplitude of 1, so this is going to go up to 3, and this is going to go up to 1, somewhat drawn to scale. All right, we know our period is 4 pi, so out here I'm going to write 4 pi, and then this is 2 pi, and this is pi, and this is 3 pi over 2. All right, and then I'm doing the cosine function, so we know the cosine function looks like this. This is my cosine function. This is my cosine function. Don't mess up, don't mess up. We're like doing well right now. We're doing well. So that is this graph right here. That has a period, a change in period, a period of 4 pi, and we vertical shifted up 2 units. Now we have to move all points right pi over 2. So pi, if this is pi over 2 is right in the middle, so I'm moving this point that much. If from pi to 2 pi, 3 pi over 2 is a middle. I'm moving this point that much. I'm moving all the, wow, that was cool. It made a perfect circle. How did I do that? That was the coolest thing ever. Now we're at 2 pi. Again, we're shifting pi over 2. Well, oh wow, why is that 3 pi over 2? That should have just been 3 pi. Okay, so we're shifting pi over 2, so it'll be this amount. All right, and then we're shifting that pi over 2, so it's that amount. And we're shifting that pi over 2, it's that amount. And then we connect. I don't know. I feel like I have too many things here. I don't know why I have that one. Don't know why I have that one. Delete it. Boom. There we go. There it is. So this is the curve. So the blue curve is this, y equals cosine 1/2 theta plus 2, and then we phase shift it to the right, pi over 2. I mean, there it is. It looks terrible. But I mean, we've done this. We've done shifting. It's just, I don't know. Just on to the next one. 29. And then, obviously, cosecant, secant, and tangent. They're all not going to be fun as I speak. Y equals 2 tangent 2 theta plus pi over 4. Oh my god. Minus 5. I don't even know. To be honest, I don't know. This is going to be rough. This is going to be so rough. Tangent's already hard. Okay, no, I got this. Amplitude, I'm not going to worry about. It's very hard to show vertical stretch on a tangent function and cotangent function. You won't be tested on that. The period, well, we know the period for tangent is pi, and we're compressing by a factor of 2. So that period, the period is going to be equal to pi over 2. Excuse me. We're going to phase shift it negative pi over 4, or pi over 4 to the left, and we're shifting this whole thing up 5 units. Okay, I think I'm gonna do the same with the last one. So I'm gonna say y is equal to 2 tangent 2 theta minus 5. We're gonna graph that, and then we're gonna phase shift. So It's just debating on what's easier. All right. I'm gonna make this period double because I want like that period to kind of be in the middle, if that makes sense. So I'm gonna say this is pi. This is pi over 2. This is pi over 4. And this is 3 pi over 4, I believe. And I believe these are going to be where vertical asymptotes are, but I'm going to double check. So if I plug pi over 4 into 2 theta, you'll get pi over 2. Tangent of pi over 2 doesn't exist because, you know, it's our y over x, and the x value of pi over 2 is 0. So I do have a vertical asymptote here. Okay, I forgot the whole vertical shift. So I'm shifting down 5 units. So here's -5. So if I shift down -5 units, instead of being a point here, normally, we're going to be a point here. I'm going to continue my vertical asymptotes. And I believe our tangent to theta that's shifted down 5 units is going to look like this. This is going to be one period. I'll do it in blue. 1 period like this. Perfect. And this is 5. I guess that's the midline for tangent. All right, continuing here. So now we have a phase shift of moving left by pi over 4. So that means we're taking every point, and we're moving left pi over 4, so therefore that point would be there. The asymptotes would also move. They would move left pi over 4. I hope that makes sense. This asymptote at 3 pi over 4 would end up at pi over 2 if we moved it over by pi over 4. And then our graph we want, again, it's this graph here, that's been phase shift or moved, translated to the left pi over 4 is going to look like and that should make sense. Like this distance is pi over 4. This distance is pi over 4. That distance is pi over 4. And we have 1 period of it. I mean, it just looks like, not good, you know, but I believe that's it. 31. This is going to be a long video. Okay, 31. So first thing first, degrees bad. So I'm going to do it in radians. So I'll do cosine of 3 theta minus pi over 4 plus 1/2. Whatever. It's not a whatever, because now there's stuff that's going to dip under the x-axis. Okay, I'll make it work. All right, so instead of graphing this, by the way, amplitude is 1. Period is 2 pi over 3, which is nasty. That's a nasty period. 2 pi over 3 is the period. Vertical shift at 1/2. Phase shift at pi over 4. I mean, they might as well have given us an amplitude at this point. I can't imagine seeing something harder than this. So this is pretty nasty. So let's graph it. I'm going to graph y is equal to cosine of 3 theta plus 1/2. All right. And I wish that wasn't a 1/2. It's like not fun. I wish it just give me 5 or 4 or negative something, you know, but fractional, not fun. So I got this. Okay. I'm going to, midline's going to move up 1/2. So to a different color, midlines y equals 1/2. Now let's talk about the amplitude. Now this is 1/2. So in theory, we can go up to, you know, 3/2. And in theory, we can go down to, I don't know, -1/2, which is not fun. Now the stupid period, dude. This period's nasty. I don't know if I'm going to put the period here or on the x-axis. I kind of just want to put it on the midline. I'll put it on the midline. It's probably illegal to put it on the midline, but I'm doing it. That's 2 pi over 3. If I cut that in half, that's pi over 3. If I cut that in half, that's pi over 6. I know my fractions. Now, between pi over 3 and 2 pi over 3, what you can do is you can add a pi over 6 to this. So this is 2 pi over 6. Let's see if I do this right. Pi over 3 plus pi over 6, if we want to, or average those two things. Maybe I should average. So I add them. Pi over 3 plus 2 pi over 3 is 3 pi over 3, which is just pi, but we want to find the average, so we divide by 2. So I believe this is pi over 2.
Yes, sweetheart.
Okay. Shoot, a bunch of people just came in. Oh, I'll work through it. Okay, so cosine, when I plug 0 in there, obviously we're going to be up here, and then we're going to be 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 here, and this right here is my cosine 3 theta plus 1/2. Okay. And then it says move it over pi over 4. Oh my god. Oh my god, that's so hard. Why? Okay. So this pi over 6 is like 30 degrees. So, oh my god, I guess this would have been easier degrees. Because then we have to have like 15 degrees. So we're shifting everything to the right. Pi over 4. And this region right here, from pi over 6 to pi over 3, is a length of pi over 6, which is not quite pi over 4. I have to go a little bit more. All right, so I have to move. We'll just say that length. We'll say that's pi over 4. You know, it's our 30 degrees plus another 15 degrees. Actually, it'd be right in half, right? I got this. It'd be right there in half. Okay, so we're going to move all our points there. So imagine the same length. So I'm going to move this point to there. I move this point to there. I move this point to there. I move this point to there, and I move that point to, like, I don't know, way over there. And this is our cosine of 3 theta plus 1/2 shifted pi over 4. Again, this shift, they're all pi over 4. It's like this length here is pi over 6, and this length here is pi over 6. So to get pi over 4, you have to have a whole length and a half. Basically 30 degrees and 15 degrees would give us 45 degrees. That might have been easier in degrees. Yeah, confident. All right, next one. And like, I'm like way over time here, you know, like, I don't think we've ever had a homework video this long. Don't know. It's so long, I got logged out of my computer. Okay. One more. Unless I give up. Oh my god, 33. This is a long homework. Y equals -2 plus 3 sine 1/3 theta minus pi over 2. Okay, this one's going to be easier. I hope. Okay. Vertical shift, -2. Phase shift, pi over 2 to the right. Amplitude 3. And period is 6. 6 pi. And the reason why on the period it's 2 pi divided by 1/3, which gives me 6 pi. Okay, I think this one's going to be easier. So what am I going to graph? I'm going to graph 3 sine 1/3 theta minus 2. Okay, so graphing that, square root of that. Okay, so I'm shifting the midline down 2. So 1, 2. Here's my midline. This is y equals 2. My period, my amplitude is 3, so I would be up here at 1, and then down here at 5. I'm kind of like off the screen. I don't know if that works out. My period is 6 pi. I don't know if I'm going to put it on the x-axis or this. I don't know. 6 pi, 3 pi, 3 pi over 2, 9 pi over 2. And then when I plot points, this is the sine function. So we'll start here, and then we'll go up to here, and then we'll go down to here, and then we'll go down to here, and then we'll go up to here, and my sine function looks like this. That's my sine function. And it says take this function and move it over pi over 2. This isn't bad. This isn't bad. Okay, so that's 3 pi over 2. So imagine somewhere in between 0 and 3 pi over 2 is pi, and somewhere in between there is pi over 2. So I'm going to say we're going to move about that much, maybe a little bit less. So we move that much, we move that much, we move that much, we move that much, and we move that much. And so my transform graph, for the most part, it looks okay. I mean, somewhat the same distance, but this is -2 plus 3 sine 1/3 theta pi over 2. Yeah, I'm going to prove it to you. I might as well kill some time here. Make it a 40-minute video. Get paid extra money. And I dropped to Desmos. All right, and I'm going to graph that standard one. So like y equals -2 plus 3 sine 1/3 theta. Okay, perfect. Looks good. No big deal. And then I'm going to graph the same one, except for I'm going to do a phase shift. And you'll be like, oh yeah, that's what ours looks like. Looks exactly like that. All right, and then here's minus pi divided by 2. And there we go. There we go. I hope. Let's see, switch to the other screen. Green, what, like maybe pull the screen over a little bit. I mean, yeah. Let's put the midline on here. Y equals -2. And let's change some colors. The base one is green. Base one is can we not change colors? Oh well. I'm going to say it's exactly the same. Sure. All right. Yeah, longest video of the year, probably. All right, thank you guys. I don't know why your teacher assigned so much. I don't know why he hates me. Thank you.